Hey everyone, today we're going to do reveal cards in increasing order. So let's get started. In a deck of cards, every card has a unique integer. Okay? You can order the deck in any order you want. Initially, all the cards start face down, unrevealed in one deck. Now you do the following steps repeatedly until all cards are revealed. Take the top card of the deck, reveal it, and take it out of the deck. If there are still cards in the deck, put the next top card of the deck at the bottom of the deck. And thirdly, if there are still unrevealed cards, go back to step one. Okay, so that's just how you go through this deck. And so now the next step is return an ordering of the deck that would reveal the cards in increasing order. So return an initial ordering of the deck that would reveal the cards when following this process to show up in increasing order. The first entry in the answer is considered to be the top of the deck. Okay, so you read from the 0th index and go on from there. Okay, so let's look at this example. Our input is this. We have to reorder the deck to kind of show it in increasing order. And immediately you see this pattern: 2, 3, 5, 7, 11, 13, 17. Right, that's the increasing order. So that's how it's actually being revealed. So let's follow the explanation. We get the deck and reorder it. After reordering, the deck starts like this, where 2 is the top of the deck. First we reveal 2 and move 13 to the bottom. The deck is now this. Okay. We reveal 3 and move 11 to the bottom. The deck is now this. We reveal 5 and move 17 to the bottom. The deck is now this. Reveal 7, move 13 to the bottom, and so on until we reveal 17 and our deck is empty. Okay. So immediately I'm seeing this kind of pattern where you go 2, 3, 5, 7, and then I'm getting screwed up when I see here. I'm expecting this to be 11, 13, 17, right? But that's not the case because of they're one step behind now. And so what I saw in one of the discussion pages is really like, rather than going in order like that, you're actually taking the smallest option, right? Skipping the next available spot and then placing it in the next available spot after that. So you place 3, now your next smallest is 5. Put it in the slot that's not been used 2 steps away, right? So 11 and then 5. Put it in the slot 2 steps away, 7. Now the next one is 2 steps away. Is first you skip 13 and then you get to 11, right? So that's why you place 11 there. Then 13 goes in the one that's next 2 stops away. So first 17 and then 13, and then 13 and then 17. So let's walk through that. So imagine you had an initialized array of just none, 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 right? So you have this, right? And our array is something like 2, 3, 5, 8, 13, right? First you put 2, right? Then you'll skip this none and you put 3. And you'll skip this none, you'll put 5. Then you'll skip this none, you put 8, right? Then you skip this none, you put 13, right? And imagine we had the same number of elements, like 18, right? Let's put 21, right? You'll skip this none, and then in the second iteration, you'll get this last none. You'll do an extra loop, but it's easier for the logic. So then this will be your starting deck. So I think that solution works. Well, let's try to do that and see how far we get. So the first thing we did, which I did not mention, is we want to sort these deck. That way we know, the ordering we want it to be output in. So let's just say our deck is now the sorted version of this deck, and our output is now actually an array of nones times the length of the deck. Okay. Now we're saying for each value in our deck, right, add it to the output in the appropriate way, right? So what we were saying was we're going to continue doing this until the deck is empty, right? As you see in this example here, right? Eventually the deck ends up being the empty array, and that's when we know. That's how we know we're done. So we'll say I equals 0, which is the index where we're at, and we'll say while the deck is not empty, right? We're going to pop off. We're going to add the 0th index of our deck to our output at the index we're at in I. So let's say deck.pop0, right? And then we want to find actually the next none, like we described, right? So let's say temp equals self.find next empty, right? And it'll give us our current I and the deck, I plus 1, actually. And then we want the second empty, right? So we'll say our new I is equal to self.find next empty of deck temp plus 1. So rather than having a function that says look 2 steps ahead, I actually prefer to do this function twice, just because it's clearer for me what's actually happening, okay? So what we're doing here is saying, okay, if we're on this, if we're here, right, and our array is something like 2, 4, 6, place the 2, right? Then find the next empty, right? Next empty is going to be this one, right? We don't want this one, we want this one. We don't want the first index, we want the second index. So we'll find the next empty after the first one, right? So that works, right? And then in cases where there's only one none left, temp and I will be the same value, and that's okay. We'll just have done one extra run of this method, which isn't going to kill us anyway. So by the end of this, the deck will be empty, and we'll return our output, because that will be the final initial ordering of our deck. Okay, so now what we need to do is actually write this helper method. So find next empty takes the deck, and it takes the index that we're starting at. This part's actually a little bit annoying. Oh, whoops, I actually noticed we don't want to pass in the deck for empties. We want to pass in our output for empties. Okay, and we're going to say we have two basically cases here, right? If we look at this case where our index is 0, and we're looking for the next none, we're going to iterate through this list, right? And basically find the next none, which is easy, right? We'll say I equals 0, or I equals index, right? While index is less than length of output, right? While we're still have room to go, if output of index equals none, right? We're going to return index, right? Otherwise, we want an index plus equals 1, right? So actually, this works for this case, right? But imagine our index initially is actually here. So our value here is 3, this value is none, and our value here is 4. So our index is 2. Immediately, we can't iterate further through this array. We have to start over from 0 and then iterate again. So what we can do, I say, okay, now I equals 0, and while I is less than the length of the output, our I is less than our original index, which is our input value, right? Because we don't want to iterate twice, right? We already passed that index, so we know there's nothing there. Let's just do if output of I equals none, right? Return I. Otherwise, I plus equals 1, and return I. Okay, so let's see if this actually works. I think it will. I hope it does. Bang. So that works. Great. Now, is it just the test case? Let's see. So our length is going to be always greater than or equal to 1. So let's just try the array with the deck with just one card. Cool. Let's try the deck with reversed order, right? And we know there's no deck that has 2 of the same card because they're all unique. So we can't have a deck that's like 17, 16, 17, right? It's going to tell me something's wrong, right? Invalid case. Okay. Yeah, so let's submit this. Sweet. Okay, that works. Thank you guys. If you enjoyed, please like, comment, subscribe, tell me what I'm doing wrong. Otherwise, tune in, get better. Thank you.